the deadliest disaster the ocean has ever set off, killed as many as 50 million people. Right now, off the coast of South America, the pattern that caused it is beginning again. It starts with a single number, 1.7 degrees. That's how far one stretch of the Pacific has warmed above normal, most of it in a single week this June. It sounds like nothing. But this is the largest body of water on the planet, and when it warms by even a degree in the wrong place, it rearranges the weather for 8 billion people. What's forming out there has a name. That name is El Niño. You've probably heard it used as a weather forecast footnote, the reason a winter ran wet or a summer ran hot. That version is harmless. It's also incomplete. Because in June of 2026, the United States government issued a formal advisory that El Niño had returned, and that it was strengthening faster than almost any event on their record. This should be leading newscasts. It isn't. Most coverage will tell you it means rain in California and a quiet hurricane season. What most coverage leaves out is the part the scientists say quietly. The part about how strong this could get. The part where the people whose entire job is to predict it have just admitted, on the record, that they can't. Stay with me, because that admission is the whole story. The name is old. Centuries ago, fishermen on the coast of Peru noticed that once in a while, around Christmas, the cold, fish-rich water they lived on would turn warm and go empty, and the catch would vanish. The name they gave that warm current was El Niño, the child, after the child born at Christmas. They were naming something they could feel, but never explain. In the deepest sense, we're still doing exactly that. To understand why a fraction of a degree matters, you have to understand what normally holds the Pacific in place. Along the equator, steady winds called the trade winds blow from east to west, from the Americas toward Asia, day after day, year after year. They do something you'd never guess from a map. They physically pile up water. Warm surface water gets dragged westward and stacks against Indonesia and the Philippines, where the sea actually sits higher and warmer than it does off the coast of Peru. On the eastern side, that same dragging pulls cold water up from the deep to take its place. This is the resting state of the largest ocean on Earth. Warm water pinned in the west. Cold water rising in the east. A balance held in place by nothing but wind. Now take the wind away. That, in essence, is all El Niño is. The trade winds weaken. Sometimes they stop. Sometimes, for weeks at a time, they reverse and blow the wrong way. And when they do, all that warm water piled against Asia comes sliding back east across the entire width of the Pacific, thousands of miles of it, like a bathtub slowly tilting. The cold upwelling off South America shuts down. The warmth spreads across the surface. The atmosphere sits on top of the ocean. Move the warmth, and you move the thunderstorms, the rising air, the jet streams that steer every storm system in both hemispheres. A single patch of warm water near the equator becomes drought in Australia, floods in Peru, a shifted storm track over North America, a failed monsoon over India. It doesn't stay out there. A strong El Niño shows up in the price of the coffee and the rice and the chocolate on your shelves, in the size of a wheat harvest half a world away, in whether the winter outside your own window is mild or brutal. Scientists track the whole thing with a single number, the temperature of one box of ocean in the central Pacific, measured against its own long-term average. Cross half a degree of warming and hold it, and they call it El Niño. That's the number that hit 1.7 in June. And that is where the routine version of this story ends. Because forecasters don't just watch the number, they watch how fast it's moving and against what. By that measure, 2026 is behaving strangely. There's a scale for these events. Cross 1.5 degrees, and an El Niño is called strong. Cross 2, and it earns a different word entirely. Very strong. Off the record, forecasters reach for a word they're not supposed to put in official releases. Super. In the entire modern record, going back to 1950, only 3 events have truly earned it. 1982, 1997, and 2015, which peaked around 2.3 degrees and tied for the most powerful ever measured with reliable instruments. In June, the American agency that runs these forecasts put the odds of this event crossing that 2-degree line at better than 60%. In their own set of models, more than half of the individual runs point to a super event by the fall, the strongest category there is. When they lined this year up against the 2 monsters everyone remembers, 1997 and 2015, they found the water in that Central Pacific box is warming faster right now than it did in either of those years, at the same point on the calendar. None of that is a forecast. It's a measurement of what has already happened. The surface number is only the visible part. Below it, forecasters watch the heat stored under the Western Pacific, a vast slug of warm water, already shoved eastward, already warmer than it should be. It rides east along the equator, tilting the boundary between the warm surface and the cold beneath. Think of it as a charge, laid down before the event even shows its full face at the surface. In 2026, that reservoir isn't just present, it's unusually deep. The fuel, in other words, is already in the tank. Say that one again, slowly. It is not simply that a strong El Niño is coming, it's that the ocean is loading the same charge that produced the 2 most destructive El Niños in living memory, and it's loading it faster. A handful of model runs, at the far edge, push the peak past 3 degrees, a number with no modern precedent at all. The deep northern winter, when these events reach their maximum, is still months away, while the warming is already this far along. The question everyone wants answered is simple. How strong does this get? Before we reach why no one can tell you, look at what the answer actually costs. To see why this reaches you, look at what the last 2 super events actually did. When the Pacific tipped in 2015, the heat didn't stay in the water, it bled into the air, and the year that followed became, at the time, the hottest ever recorded on the surface of the Earth. Coral reefs across the tropics, including vast stretches of the Great Barrier Reef, bleached bone white and died in the overheated water, in one of the largest die-offs anyone has documented. The 1997 event rewrote rainfall across half the planet, drowning parts of South America, while it dried Southeast Asia and Australia into a fire season that buried cities in smoke. A strong El Niño reaches into global harvests, into the price of staple food, into the spread of disease, into which regions flood and which ones burn. It's the closest thing this planet has to a single switch that resets the weather everywhere at once. For North America, a strong one usually means a storm track that slides south, a string of atmospheric rivers slamming into California, a Gulf Coast that turns wet and stormy, and a northern tier that runs strangely warm. Which winter you get depends on a patch of ocean you'll never see. Those were the events that peaked, did their damage, and let go. To see what this force does when it doesn't let go, you have to go back 150 years. In 1876, the monsoon that India depended on to grow its food did not arrive. Across the Deccan Plateau, the crops failed, and the next year, they failed again. The same failure struck northern China and Brazil and Egypt, Morocco, the Horn of Africa. 3 continents, 1 cause, the same 2 years. When historians and climate scientists later added the numbers together, the drought and the famines that followed had killed somewhere between 30 and 50 million people. 3 to 4% of everyone then alive. It remains, by a wide margin, the deadliest environmental disaster in recorded history. For a long time, no one knew what had done it. The answer came from the ocean. When researchers reconstructed the sea surface temperatures of those years, they found the fingerprint of an El Niño, and not an ordinary one. A team publishing in a peer-reviewed climate journal concluded that the 1877 event was very likely the strongest on record. Stronger than 1997, stronger than 2015. The warmth in the Pacific held for 16 straight months, long enough to reach across a hemisphere and pull the rain out from under half the world at once. We had no satellites in 1877, so that ranking is reconstructed, and the uncertainty around it is large. But run that uncertainty the other way. If we can't be certain the worst El Niño in history was truly the worst, then we can't be certain that nothing since has matched it, or that nothing forming right now will. Which is exactly what the forecasters are staring at this summer. Not the past. The blind spot in the present. We are not blind the way the people of 1877 were blind. There are buoys strung all the way across the equatorial Pacific, taking its temperature in real time. Satellites watch the sea surface from orbit. Supercomputers run the physics of ocean and atmosphere forward in time. By every measure, we should be able to see one of these coming and tell you exactly how large it will grow. For an event already underway, once it has locked in, we largely can. What we can't do is tell you, before it commits, whether it becomes a monster or fades into nothing. The reason comes down to how these events are born. An El Niño doesn't grow on a schedule. It grows when the ocean and the atmosphere catch each other in a feedback loop. Warm water weakens the winds. The weakened winds let the water warm further, and around it goes, each one amplifying the other. Scientists have a name for that runaway loop, and once it truly locks in, it's close to unstoppable. Getting it to lock in is the hard part. The thing that first tips the loop into motion is a burst of wind from the west, sometimes riding a slow pulse of storminess that circles the tropics, a sudden reversal that can last only a few days and shoves warm water eastward to give the feedback its first push. These westerly wind bursts are, in the words of the scientists who study them, effectively weather. They flare up and vanish on the timescale of a passing storm, and forecasters can only see them reliably a week or two out. Whether this year's El Niño becomes the strongest in a century may hang on gusts of wind that haven't happened yet, winds no model on Earth can predict more than days in advance. The trigger for a planetary event is, in part, random. And that randomness, strangely, is the part we understand. Picture the forecaster in spring. This is their whole job. They have the buoys, the satellites, the models, decades of training. They sit down in April to tell the world what the ocean will do by winter. Every spring, at exactly the moment the world most wants an answer, the science goes quiet on them. There's even a name for it, half joke, half confession. The spring predictability barrier. For reasons still not fully understood, the tropical Pacific in spring becomes almost opaque to prediction. One study measured it bluntly. In late spring, our best physical models capture less than a third of what the system actually goes on to do. The signal drops, the noise rises, and into that fog the models keep issuing confident forecasts that turn out wrong. In 2014, the models were nearly unanimous. A powerful El Niño, possibly a great one, was on the way. Headlines were written. It didn't come. The event fizzled to almost nothing, and no one had cleanly predicted the failure. Then, the very next year, 2015, those same models looked at the weak leftover warmth and forecast that it would fade by spring. Instead, it did the opposite. It exploded into one of the two strongest El Niños ever recorded. One scientist at NASA's Jet Propulsion Laboratory, watching the warm water pile higher week after week, started calling it the Godzilla El Niño, and the name stuck. The forecasters named the failure of 2014 only after it had already failed. They didn't see 2015 coming until it was on top of them. A researcher who now runs a multi-year project just to study these false alarms put it plainly. After years of looking, they still can't pinpoint any single reason the confident forecasts break. So here is the rule we all quietly assume. We built the instruments, we launched the satellites, we wrote the models, so we must be able to see this coming. And here is the exception that breaks it. The single most consequential climate pattern on the planet, the one that can reach across a hemisphere and empty the granaries of half the world, is driven at its very trigger by winds we can't forecast, through a season we can't see through, by a mechanism no one has fully explained. We can watch it happen. We cannot tell you where it stops. So let me leave you where the forecasters actually are, in the summer of 2026, watching a number climb. It showed 1.7 in June. Every week, it ticks higher. The advisory is out, the models agree it's strengthening, and more than half of them say it becomes a super event before the year is done. The deep winter, when these things peak, hasn't even arrived. Somewhere out west, over water most of us will never see, gusts of wind are either about to fire and shove this thing past every event in the modern record, or they aren't. No instrument on Earth can tell you which. The last time this force grew unwatched, the number was 50 million. 3 continents. 16 months of warmth that pulled the rain out from under a fraction of the human race. The world of 1877 had no advisory, no buoys, no satellites, no warning at all. And the countries that suffered most back then are far better fed and far better warned today. But a strong El Niño still leans on the whole planet's food system at once. And from the Sahel to the Horn of Africa, a failed rainy season is still counted in lives. We're better prepared than they were. We are not immune. And the one thing you'd most want, we still don't have. The ocean is warming off the coast of South America right now, as you watch this. 0.5 degrees. Then 1. Then 1.7. The largest thing on the planet is exhaling. It has done this before, and the people who spend their whole lives trying to read it are watching the same number you are, and admitting, out loud, that they don't know where it ends. The number is still climbing. The question was never whether anyone is watching. We are. The question is whether watching was ever going to be enough.